So this is what we had covered so far. Okay, I told you, okay, you have metals right at the bottom of the reactivity seas, which are found in the native state. Even if they're not found in the native state, they might form compounds. You can make aqueous solutions out of them. And what you can do is you can then do electrolysis, ठीक है, of those aqueous solutions. So copper का example था कि you can find copper in the native state, or you can dissolve the copper compounds by dissolving it in an acid and make it a solution and then do electrolysis. So copper is unreactive, so it will be obtained, or it will be reduced at the cathode. It will be the one that would be gaining electrons. And then you have a reduction with H2. Okay, even hydrogen gas is more reactive than copper, so hydrogen gas can sort of take away the oxidants from the copper compounds. Anyways, we were at extraction of iron. I told you there were many ores of iron, hematite being one of them, and carbon is more reactive than that. So what you do is you add carbon to it, and carbon takes away the oxidants from hematite, and you can balance this. So to do this specific thing, you use a blast furnace. In the blast furnace, what is done is, okay, you mix these three things. The first thing is that hot air is blasted. Sorry. So the first thing is that hot air is blasted from the bottom of the blast furnace, and the coke catches fire. So the coke ignites, catches fire, and starts to burn. So coke over here just hold on a second. So coke over here catches fire and starts to burn. And it's an extremely exothermic reaction. What happens is that carbon, I mean, you know that coke burning, carbon burns and ends up producing carbon dioxide. So it's exothermic, which means that it produces a lot of energy, and the heat that is produced melts the entire mixture. Which is why you get molten iron in this reaction. So you have to remember everything about this. Then what happens is that the same carbon dioxide that is produced, as the carbon dioxide rises, it meets even more coke. Remember, there's too much coke added, which is a type of coal, and it gets reduced to carbon monoxide. So eventually you get carbon monoxide because there's not enough oxygen or air that is being blasted from the bottom. And then what happens is that iron gets reduced, or hematite basically gets reduced. What that basically means is that Fe2O3, the molten Fe2O3 now comes into contact with carbon, and carbon being more reactive is going to take away the oxidants and it would form carbon dioxide, and Fe molten iron would be produced as a result. And the same hematite Fe2O3 will also come into contact with carbon monoxide. And again, carbon being the more reactive one is going to take away the oxidants, form carbon dioxide, and Fe is going to be produced. So there are two reactions that are going on. And to balance this equation, there should be, I think, how do you balance this? This should be 2. This would be 4. This would be 3, and this would be 3, I think. To balance the other one, how do you balance the other one? You again make it 6 oxygens, I think. 3 CO, 3 CO2, 2 Fe. And let me just quickly check, is the first equation balanced? That's 6 oxygens. So the first equation is balanced. What about the second one? Just let me just double check. In the second one, there's only one Fe2O3. Because that's 6 oxygens over here, 3 carbons, 3 carbons, 2 Fe's. This should be 2 Fe's over here. That's it. So now this equation looks balanced. So what you have is you've got hematite that's getting reduced. So this is what's going on. Starting from the bottom, you had coke, which catches fire and starts burning, and it produces carbon dioxide as a result, and it's an exothermic reaction which melts the whole mixture. Then what you have is you've got carbon dioxide getting reduced by coke. It gets reduced by coke because you've added a lot of coke. And then what happens is that the molten hematite comes into contact with carbon and ends up producing carbon dioxide, and iron is produced. So you get molten iron is obtained after this reaction. Ye clear है सारों को?
Yes, sir.
Achha, molten iron is obtained. Achha, then very important point is, what's the purpose of limestone? Okay, so why do you add limestone to the whole thing? The purpose of limestone is that it's used to remove impurities. What it does is removes impurities. Mainly the impurities are sand, which is SiO2. So it removes that specific impurity. The carbonate first decomposes. So what you have is CO3 decomposing to form CO plus CO2. And then this CaO is basic. And if it's basic, it's going to react with SiO2, which is acidic. Non-metal oxides are acidic. Metal oxide, so it's a metal oxide reacting with a non-metal oxide. So you've got a metal oxide reacting with a non-metal oxide. And when these two react together, they form calcium silicate, which is known as slag. Slag, or better known as calcium silicate. So this slag is produced. And the thing with slag is low density. And it floats on the surface of molten iron. So remember, in the previous reactions, you did get iron. So right at the bottom, you're going to get this molten red hot iron in liquid state, and the top surface is going to be slag. So you're going to see molten iron, and slag is going to be this top layer over here. Another very good thing about slag is that what it does is slag prevents oxidation of iron? Oxidation of molten iron. How does it do that? Because it provides a coating of on top. So the coating of slag it kind of prevents iron from getting in touch with oxygen or getting in contact with O2. Okay, that's the purpose of slag. So this is all that's happening here. Okay, so hot air is blasted. In the blue over here, that's the first reaction that happens. That's the first reaction that happens. Okay, that coke starts to burn. So the carbon dioxide also gets reduced when it reacts with even further more coke. Carbon and carbon monoxide are able to take away oxidants from iron oxide, and iron is produced. And the molten iron is obtained at the bottom. And slag is used to remove impurities. Okay, that helps in the removal of impurities. Is this all clear?
Yes, sir.
अच्छा फिर उससे आगे के the iron that is produced, it's not pure iron. Okay, so the molten iron that's produced, this one over here, it has a lot of carbon. Because not all the coke must have reacted. So it's got a lot of and what is formed when iron and carbon are mixed together? Iron and carbon, if you mix them together, what you basically get is steel. Steel is obtained when iron and carbon are mixed together. So you're going to get steel, and there would be three types of steel. The first one is going to be a very raw form of steel, which is known as high carbon steel. Okay, that's number one. So high carbon steel is also known as wrought iron or cast iron. So that's high carbon steel. When you have high carbon steel, it's only used for raw usage because it's an alloy. It's not very flexible. And when something is not very flexible, it's bound to crack. Not very flexible can also be called not malleable and ductile. So that is your high carbon steel. And as it's used for raw usage like wheelbarrows, I mean gardening tools, I mean you can make a hammer out of it. So because they're not very flexible, if you want to hammer something, you're going to hammer something that is solid, which is not flexible. That's number two. What is done is oxygen is blown through molten iron. You blow oxygen through it. So you blow oxygen through it. Now this is iron plus carbon basically, and a pipe is inserted which blows or bubbles oxygen gas. And when that is done, when oxygen gas is blown through it, the carbon reacts and turns into carbon dioxide. And it turns into carbon dioxide. So the second type of steel is known as mild steel. And let me add to get rid of high carbon content. ठीक है, is this clear? What's this clear?
Yes, sir.
अच्छा, second is you've got mild steel. Mild steel में low carbon content होगा. When something has low carbon content, that basically means it's flexible. So it's flexible, or you can call it malleable. And also ductile. तो ज्यादातर जगहों पे ना यही यूज हो रहा होता है क्योंकि it's flexible. Machines, car bodies, etc. You want steel to be flexible in a lot of places क्योंकि ताकि वो impact absorb कर ले. So machines, car bodies, bend हो जाए, crack ना करे, ठीक है? So you want steel to be like that. And the third type of steel is stainless steel. Just hold on one second. अच्छा, sorry. अच्छा, stainless steel, that's the last one. कि stainless steel में क्या होता है कि you've got अच्छा, stainless steel में क्या होता है, you've got iron plus carbon plus chromium होता है बीच में, ठीक है? So it's Fe plus carbon plus you've got chromium mixed into it. What chromium does is कि chromium के ऊपर ना top layer हो जाती है that it forms a very shiny top layer of chromium oxide. ठीक है? chromium जो होता है स्टील के अंदर ना वो रिएक्ट कर जाता है oxygen from the air and forms a chromium oxide layer, which is why it's a shiny layer, shiny and tough layer, which prevents rusting, which provides protection and kind of prevents rusting. तो stainless steel is most of the time rust free. तो इसमें क्या क्या यूज होता है? Cutlery, you have your surgical instruments, so all these things are made from stainless steel. तो ये सारा याद रखते हैं इसके बारे में, blast furnace से लेके all the details have to be remembered about extraction. Now the reaction is pretty simple. It's I mean the summary of the reaction is that carbon comes along and it removes the oxygen from the hematite. Like in the actual reaction is a bit complicated. Okay, you've got limestone being added. How is heat being produced? Who's taking away oxygen from the hematite? तो क्या क्या raw materials use हो रहे हैं, ठीक है? So you have to remember all of that, ठीक है? Is this all clear?
जी सर.
अब फिर अगला क्या है? The next one after that is if you go back, तो वहां पे उसके बाद जो चीज है ना, I mean elements that are very reactive, you can't do reduction with carbon. ठीक है? You can't reduce with carbon. They're very reactive. So carbon will not be able to take away whatever is attached to them. So can't reduce with carbon, can't do electrolysis of aqueous solution because in aqueous solution H+1 is a lot less reactive. So can't do electrolysis of aqueous solutions. As H+1 ions are going to get, they're the ones that are going to get discharged. तो इसके अंदर पीछे आपके पास सिर्फ एक ऑप्शन रह गया, only electrolysis of molten electrolytes are done. Only that is done, nothing else. So, I mean, for example, if I go back and have a look at NaCl, like how would you extract sodium metal? The only possible way is electrolysis, but not of aqueous solutions, but of molten NaCl. So if I want to extract Na, so if I want to extract Na from NaCl, this is what's going to be done. You'll take a container, connect 2 electrodes to it, preferably inert electrodes. Once that is done, after that, what you're going to do is you're going to put molten NaCl, not aqueous, but molten. So molten NaCl, there's only going to be sodium ions and there's going to be just Cl ions. That's it, 2 things. Battery जो है वो एक side electrons दे रही होगी, so the electrons are going to go to Na. So Na is the one that's going to gain electrons and form sodium metals. दूसरी side पे battery would be getting rid of electrons, removing electrons. So Cl-1 would be the one that would end up losing electrons. So, and it's diatomic, so there would be 2 Cl-1 ions they would lose 2 electrons to form Cl2. So chlorine gas is going to be produced. But the thing is, the important thing is कि यहाँ पे आपको ना you're getting sodium metal. So that is electrolysis of a molten electrolyte. So यहाँ पे one electrolysis that is going to be done in detail is going to be the electrolysis of aluminium, and you have to remember every single detail about that. So extraction of aluminium. अच्छा, extraction of aluminium में कि you've got bauxite, which is the ore of aluminium. It's got Al2O3. I mean, that's the main component of bauxite. Plus, it's got other things as well. It's got impurities in it. Lots of them. And mainly, the impurities are iron oxide and other metal oxides. ठीक है, ये सारी आपकी impurities हैं. And the step 1 of the reaction is you've got to get rid of the impurities. Now, how do you remove impurities? That's step 1. The way you remove impurities is कि आप उसको क्या करते हो कि bauxite is amphoteric. That means it can react with acids and bases both. So what you do is you dissolve it in NaOH, which is a base. And sodium aluminate is produced. And a water molecule. So you have an acid-base reaction. And Al2O3 dissolves. These other metal oxides, these are basic. So if they're basic, so NaOH, that's also a base. So base is not going to react with a base. There's not going to be any reaction. So there's not going to be any reaction, no reaction. So what happens is Al2O3 dissolves in NaOH. But Fe2O3 dissolves in NaOH. Why? Because it's amphoteric. And Fe2O3 and other metal oxides don't dissolve as they are basic and are later filtered off. ठीक है, is this clear? ये पहला step है, step number 1, and that is removing impurities. So ये clear step number 1 के Al2O3 has to be, because you can't reduce it using you can't reduce it using carbon. aluminium, Na, etc. तो उनका molten का electrolysis. And how do you dissolve Al2O3 and the other metal oxides are not going to dissolve because other metal oxides are basic, whereas Al2O3 is amphoteric. So here, let's continue next time. वो समझा कल हम ट्राई करें. मैं अभी गला खराब है, कल हम ट्राई करते हैं कि we'll have a pass paper class. ठीक है.
Okay, sir.
Sir, what time will the class be?
Ani, where are you right now? Pakistan?
Yes, sir.
So ठीक है, let's try 1. ठीक है.
Okay, sir.
Okay, Allah Hafiz.
Allah Hafiz.